Hello students, so this is my fourth lecture on optics. In my last lecture, I have discussed about the relation between focal length and radius of curvature of concave mirror by using the concave mirror. So today, I derive the same relation with the help of convex mirror. Okay. Now, here you can see that this is a convex mirror with pole P, focus F and center of curvature C. Now we consider one ray PO parallel to principal axis and incident on the convex mirror at point O, and after reflection it will goes in the direction or diverge in the direction OQ. So here PO is the incident ray and OQ is the reflected ray. Okay. So they are reflected ray. You will see that the reflected ray appears to come from the back side of the mirror from point F, that is the focus. So we join this reflected ray by dotted line in focus. Okay. Now we draw one normal from the center of curvature. This is the normal to the mirror at the point of incidence. So this angle will be equals to this angle by loss of reflection, that is angle of incidence equals to angle of reflection. So you can write, suppose angle QO, you take it as and this QO and this equals to PO and this, that is equals to theta, stays. Okay, this angle equals to this one. How? From loss of reflection. Okay. Now again we draw one normal from point O to the principal axis, that is OM. This one normal we draw. Now here the angle, you can see that this angle and this angle, these two angles, that is angle OCP and angle QO and this equals to angle QO and this angle and this angle. How? Because these two are corresponding angles. Okay, these two are corresponding. If you see that this is one parallel line and this is the intersector, so this equals to this is the corresponding angle. Okay, so angle OCP equals to angle QO and this equals to theta. How? It is corresponding angle. Okay. Now, since this is a normal, so triangle ON and C is a right angle triangle. Okay. This ON is a normal to the principal axis from in point A. So O and C is a right angle triangle. So you can write from triangle ON C, ratio of tan theta equals to this tan theta. So what is the perpendicular? O is the perpendicular. So ON by base is NC. Here base is NC. Okay. Now this is the tan theta equals to ON by NC. So give me equation number 1. Okay. Now this for this convex mirror, the aperture is small. I already told in previous case, in for case of the concave mirror, that if the aperture is small, so we take the small aperture concave mirror, and this is the small aperture convex mirror. Since the aperture is small, so this angle will be also small, and since the aperture is small, so point P lies very near to point N. This N point is very near to the point P. Okay, so we can write, since aperture is small, so theta is also small, and N is lies very near to point P. So theta is small and N is lies very near to. So then we can write that tan theta is almost equals to theta, and this NC is equals to PC. Okay, equals to PC. Equals to, what is PC? What is PC? This is R, radius of curvature. What is PC? Distance between the pole and center of curvature. So it is equals to R. Okay. So this equation 1 become equation 1. It will be, you can write theta equals to ON by R. Give it equation number 2. Okay. So number. Now again, this triangle. Okay. From this triangle, this angle, you can see the angle QOP equals to angle OFP. Same. These two are corresponding angles. This QOP and OFP corresponding angle. So this theta plus theta, twice theta. So this total angle is twice theta. So this angle will be also twice theta. This angle will be also twice theta because of the corresponding angle. So you can write angle QOP equals to OFN, that is equals to twice theta. How? Because of corresponding angle. Okay? Corresponding angle. So again, if you consider this triangle O and F, this is also a right angle triangle. So from triangle O and F, this triangle, right angle triangle. So what will be the tan theta? Tan here in place of theta, this is twice theta. Tan twice theta will be ON by NF. ON by NF. Perpendicular by base. This O and F. So if this perpendicular by base, then we can write, since the aperture is small, so we can write tan, since aperture is small, so we can write tan twice theta is almost equals to twice theta, and NF equals to PL, that is equals to F. This is the focal length F. Focal length F. Okay. So now, suppose this is equation number 3. So equation 3 will be, equation 3 implies, what we will get? That twice theta equals to ON by F. Twice theta equals to ON by F. So give it equation number 4. Give it equation number 4. Twice theta equals to ON by F. And give it equation number 4. Now see, from 2 and equation 4. From 2 and equation 4. From equation 2 and 4. two equation, then we will got that R equals to okay, twice F. R equals to twice F. That means from this equation we can write F equals to R by 2. F equals to R by 2. That is the focal length of a spherical mirror, that is we are using, that is convex mirror, is equal to the half of the radius of curvature. Half of the radius of curvature. So we prove the relation of R and relation between the R and F, its focal length and radius of curvature, by using the convex mirror. So these two. So go to the previous class and previous class. This is very important. Okay, and I will give some numerical. So try to solve it. Okay. Thank you very much.